It's the world's most famous clock. It's just turned 150. But with problems ranging from an aging mechanism to constant attack by pigeons to a rather worrying tilt, will Big Ben make it to the next century? At 150, the challenge for this icon's caretakers is to keep Big Ben standing and in perfect working order for the next 150 years. The stonework faces constant threat from pollutants. Marauding birds make unrelenting work for specialist glaziers. And construction work nearby has undermined its very foundations. With a clock mechanism that's older than any living human being, making sure Big Ben stays upright, clean, and in perfect time is no mean feat. For the first time on television, we'll go behind the scenes at Big Ben, following the specialist crews in their daily struggle to keep the clock tower up and running, and prepare Big Ben for Remembrance Sunday, honouring Britain's war dead, when all eyes and ears will be on the great clock tower. Big Ben is one of the most recognised landmarks in the world, but it's cared for by just a handful of professionals, from metalworkers.
Wherever you are on the planet, if you hear the chimes of Big Ben, you don't just say, "Ah yes, bells," you say, "Ah yes, Big Ben."
To glaziers.
I've been working on the clock face of Big Ben for the last 20 years, I think. It's a privilege to do this work.
And three wise men whose job it is to keep the great clock running smoothly and accurately. Ian Westworth, Paul Robeson and Hugh Smith are the clockmakers who share the responsibility of looking after the great clock. They're based in the workshop deep in the bowels of the Houses of Parliament, and they just love clocks.
I started an apprenticeship straight from school. I worked on clocks and watches to start with, and I've been doing it for all my working life, over 30 years. Even when I was doing watches, I always enjoyed doing clocks a lot more as a hobby, and particularly English clocks. I like English clocks. English clocks are nice and heavy and robust, and you can work on them.
I think I've always been interested in machines and small machines, motorbikes, cars, that sort of thing. When I'd actually left college, I then specialised in turret clocks, big church clocks. And then when the opportunity came to work on the Great Clock of Westminster, or Big Ben, obviously it's an opportunity too good to miss.
Paul, Hugh and Ian are responsible for around 1,500 smaller clocks all over the Palace of Westminster. At the crack of dawn, they begin their mammoth round of clock winding. They have to be done before the parliamentary staff arrive for work.
We have about 400 mechanical clocks, so what we do every day, we come in, we do about 100 mechanical clocks. We do little sections throughout the whole building. We've done the Lords today. Yesterday we'll have done the Commons, upper committee corridors and stuff like this, so each area we do on a set specific day, otherwise the clocks will all stop.
These days, only about a third of the 1,500 clocks in Westminster are still mechanical. The craftsmanship of these men is gradually becoming a lost art. Once the clock winding inside the palace is over, the three make their way to the granddaddy of clocks. Big Ben's clock mechanism sits 58 metres above the streets of London. When the clock tower was built in the 1850s, lift technology was very new and not able to cope with a building so high. So 3 times a week, the clockmakers have to make their way to the top, as their predecessors did. They take the stairs, all 334 of them.
That's 9,000 metres a year. So we've done, it's looking at 6, 7, 8 Everest trips. But it doesn't get any easier. I assure you, it doesn't get any easier.
The first week I started, we were doing maintenance on the clock, and I came up and down 10 times in one day.
The man who was here before us, and he says the first 20 years are the worst, followed by the second 20. So we've got a long way to go yet before we're in that sort of row.
This is the mechanism that drove the heart of the British Empire. But this is not Big Ben. The term Big Ben refers to the hour bell itself. No one knows for sure how the bell got its nickname. The most likely theory is that it's an affectionate tribute to MP Sir Benjamin Hall, who supervised the installation of the original bell. Big Ben weighs over 13,500 kilos and is more than 2 meters tall. It's surrounded by 4 quarter bells, and when the hour is struck, they play a short extract from Handel's Messiah. With Big Ben's face, body and heart cared for by their specialist teams, back down on the ground is Principal Surveyor John Prue. His job is to keep the clock tower standing. But it's not as simple as it seems. Because the site on which the palace now stands was not always on firm ground. In fact, it was once an island in the Thames.
The clock tower is located in an area, we believe, probably of a mix of materials with softer underlying silts and estuarine deposits. The main factor causing the tilt of the tower is the underlying nature of the geology on which the tower was constructed. And you have some very soft material on the edge of the tower, which is more compressible than on the other side. And so that is what is causing the tower gently to lean over.
An official document drawn up during the tower's construction shows that it was starting to lean even while it was being built.
And here, the movement was nowhere near as much as Pisa, but they did notice there had been some movement because they started getting some cracks. And since then, it's been kept monitored at various stages in its life, but most notably in the last 10 or so years.
The graph shows a steady increase in the lean of the tower up until the 1990s, when it appeared to settle down. Then in 2003, for reasons unknown, there was a sudden spike in the readings. Since then, it seems to have stabilized. But this increasing angle could have severe consequences.
As the tower does lean over, it puts more load on one side than the other, and clearly if that becomes too excessive, then the stone would start to crumble.
John Prue is planning a series of tests to see whether Big Ben's tilt is likely to become critical. But he has to find this out before it actually happens, or Big Ben may not make it through the next 150 years. At London's Big Ben, a small but dedicated team are making sure that a tilt and aging parts don't hamper its future. This hasn't always been an easy task. The Palace of Westminster sits on the north side of the River Thames and is dominated by 2 towers, the Great Clock Tower and the Victoria Tower, which is home to thousands of Acts of Parliament dating back hundreds of years.
I'm in the Acts Room of the Parliamentary Archives at the Palace of Westminster, and these acts on rolled parchment go back to the time of Henry VII in the late 15th century.
There's been a royal building on this site since the 11th century. It was used as a royal residence as well as a centre for government. But in 1834, disaster struck.
A disastrous fire took hold of the Palace of Westminster, and about 2/3 of the old buildings were destroyed. It was due to the overheating of a boiler underneath the House of Lords chamber. It was necessary then to have a competition, and 97 entrants put forward their designs, but one stood out for its clarity of plan and its beautiful detail, and that was by Charles Barry.
Barry's original design didn't feature a clock tower, but a few months after winning, he had an idea.
It was only after a while that he revised his designs and a clock tower was introduced.
Barry designed the clock tower to be an elegant structure, enhancing the palace and securing its place as the nerve centre of the British Empire. The mid-19th century was a scientific golden age, but up until 1833, there was no standard time reference across the whole of England.
We had different time zones across the country, from west to east, with the west, say Plymouth, was 16 minutes behind London because each town would just use the rising and setting of the sun to measure its clocks. This, with the faster communications such as the railways and the electric telegraph, was not convenient, because if you had to timetable a railway, you had to have one time right across the country.
The new clock would broadcast Greenwich Mean Time, and the rest of the world would take its lead. It had to be incredibly accurate. The Astronomer Royal insisted that the great clock for Westminster be accurate to within 1 second a day, a feat thought to be impossible for an outdoor clock exposed to the elements.
One of the big problems with turret clocks are that the size of the hands get affected by wind, basically. The wind comes along, our minute hands are 14 feet long.
I think that's an interesting thing.
This one piece will make 52 layers.
Watch on mobile devices or the big screen. All for free. No subscription required.
But an amateur clockmaker called Edmund Denison was convinced he could solve the problem. Working with Edward Dent, who'd been commissioned to build the clock, he came up with an ingenious solution to make the new clock windproof.
When they built the clock was ready, but the tower wasn't. So it sat in Dent's workshop for nearly 5 years, and they had time to experiment on it. And one of the things that they experimented with was this double three-legged gravity escapement.
Denison's ingenious design was for a self-propelled mechanism with 2 weighted arms that would effectively push the pendulum from side to side at a constant speed. It meant that the clock would keep perfect time, whatever the weather.
It's fantastic because none of the energy that hits the hands comes back and affects the pendulum, and the pendulum is the timekeeping bit, and it is groundbreaking.
The clock is divided into 3 sections known as trains. In the middle is the device that operates the hands of the clock and triggers the bell mechanisms. On the right is the chiming train for the quarter bells, and on the left is the train for the hour mechanism that strikes Big Ben itself. All 3 trains are powered by gravity, with a weight unwinding a wire wrapped round a large barrel. To ensure that the pendulum is protected from vibration and other external forces, a large part of it swings in a deep pit made of cast iron. The pendulum itself is a zinc rod in an iron tube, which compensates for temperature changes. All this has secured Big Ben's reputation as the most accurate 4-face chiming clock the world has ever seen. But how do they know what time to set it? The answer: they do what everyone else in the UK does. They phone the speaking clock. At 10 minutes to the hour precisely, Paul starts a stopwatch on the 3rd pip.
We phone the speaking clock at 10:02. I start the stopwatch exactly 10:02. We should come up here and I watch the hammer hit the bell on the first stroke of the hour. That is the exact o'clock. It's 0.3 of a second out, so with a bit of luck, no complaints today.
And should the clock be running fast or slow, there's a rather old-fashioned but time-honoured way of adjusting it.
If we need to make any adjustments, if we do the time check and the clock is running a little bit slow, it's not like a conventional clock where we can just move the hand on it a little bit, or like your watch, you reset your watch. So if the clock is losing a bit, the way to get it back onto time is to speed the clock up. The pendulum is swinging every 2 seconds. So what we have is this tray up near the top of the pendulum, and there's various weights on here, but amongst the weights are pre-decimal pennies. And by adding one of these pennies, what you're actually doing is moving the centre of gravity up. So you're effectively shortening the pendulum. So by adding one of these pre-decimal pennies, we're actually speeding the clock up by 2/5 of a second a day. We take one off, we slow it down by 2/5 of a second a day, and that's the way we get the clock back on time.
While tiny adjustments are being made to the clock's beating heart, its face is having a makeover. Tony McCarty is a specialist glazier with a head for heights.
I'm just removing the old putty that holds the glass in. And once I've done that, I will then take a template, a paper template of the shape of the glass before I remove it. It's broken, so I won't have no record of the size. What people forget is that behind this pane of glass, although it's a hard cast iron frame, you've got these very delicate capping pieces. So if you don't remove this carefully enough, you can damage the external face very easily.
In order to replace the capping pieces, Tony will require some help from a pair of specialist abseilers, as the only way to reach them is to be suspended in the air off the side of the tower.
I get a bit nervous, excitedly nervous, I suppose, on the morning. Head down, back towards me. I've been working on the clock face of Big Ben for the last 20 years, I think.
Yeah, well, it's got to come out, hasn't it?
Yeah. I've only had toast today. One slice of toast this morning. And my last cup of tea.
It's not your last cup of tea, it's the last one you drank.
That's right. I'm getting a bit dramatic now.
Should be okay.
You are for the moment.
Yeah.
What we're going to do with that is get that out of the way. Now what I'm going to do is, as you're going over the edge, I'm going to gradually start feeding this down.
Yeah.
Until it's at a point where you and Dave are happy.
Glass breaks or becomes dislodged by either vibration from the clock, vibration from the road. If rain gets driven into various cracks and crevices and freezes during the winter, it expands, it can fracture the glass and push it off, and heat from the sun can cause the glass to fracture.
That's it in?
Yeah. Yeah.
How about putting them in your crow, Dave, with your cows up?
This major operation is to replace a capping piece. These are the glass coverings which seal the cast iron skeleton of the clock face.
This is white fluorescent glass. It's called pot white. It's white all the way through. It's a classic glass. It's used historically in most clock faces throughout Great Britain. It diffuses any objects behind the lights. So when you look from downstairs, you don't see the light bulbs that illuminate the clock.
Tony has replaced the broken glass, but that's the easy part. The hard part is getting back up.
Yeah, I will do. I'll finish with that now.
watch that head.
You still have to be mindful, particularly where your feet are. And when you're ascending, you tend to be looking up. And so you still have to really concentrate on where your feet are. Historic buildings like this, you can't afford to damage them. And that's... Whereas normally you'd be able to just climb up without too much worry. You have to be really careful about where you place your feet and you don't cause any damage. And I think that is the issue, up and down, but probably more up.
Let me know when you're ready and I'll pull you through.
I'm ready.
Absolutely cracking.
That's it. That's the time, that was, wasn't it?
Look at that.
Okay. Thank you.
Right, well done, son. Well done, that man.
Thank you, Paul.
You've done well.
Thank you very much.
Big Ben's face is back to its impeccable best. But it's not just the elements that constantly threaten to give it a black eye.
I heard a pigeon flew into the glass once, but I don't know whether that's an old wives' tale or not, but I think that can cause a problem if it's a very big pigeon.
Pigeons and gulls are the scourge of London's buildings. Not only are they flying bricks, but their corrosive droppings eat away at the stonework and disfigure the elegant facades. But while the majority of London's buildings resort to ugly spikes or nets to keep the birds at bay, the Palace of Westminster has a much cleaner, more efficient process. Angela and her husband Mark are part of Parliament's pest control team. The other members of the team are 6 Harris hawks. Their job, to keep pigeons and gulls away from the palace.
The biggest problem is guano, and the problem with that is it's quite acidic. It will actually eat into the fabric of the building. And this is a building it would be quite difficult to replace. This is Electra, but we fly her out here quite often because she's so big. She's actually got the size and weight to really worry the gulls. They're warning all their friends and relations that there's a predator in the area so that they can all take to the skies and be safe. They want to keep above him, they want to keep away from the toughest kid on the block. Our children name the birds. So this one's Electra. We also have Angel, who is named after Angel from Buffy the Vampire Slayer because we had a vampire theme. Yeah, his brother is Blade. So I'm this far away from having a hawk called Spider-Man.
For the Harris hawk, the goal is unrelenting. Keep the birds away from Big Ben.
It's a deterrence, but it's a deterrent system that doesn't make any awful noises. By definition, very green. We don't leave anything behind. If you put nets or spikes up, you ruin the look of a building. Once we take the hawk away, the building's exactly the way it should be. Because he's slower than the pigeons and the gulls that we get here, though he looks scary, we don't catch anything. So we're keeping them away in the gentlest way possible.
On the 29th of April, the unthinkable happened. Big Ben went wrong. The Clockmakers had to carry out emergency repair work in the dead of night. The 5th of August, 1976. A 4-ton weight came crashing down inside the clock tower. It broke the entire mechanism and brought the clock to a standstill. After more than 100 years of service, the fly fans regulating speed wore out, causing the cable to unravel out of control. It looked like a bomb had gone off. After a messy repair job, the search was on to find a way to make sure this never happened again. Enter the National Physics Laboratory, where a crack team of scientists worked away at the problem until they came up with an ingenious solution.
If the clock speeds up more than 50% of its normal running speed, the balls on those ramps are thrown out. They engage in this outside drum here, and that operates 2 brake arms which clamp onto the outside of this original driving wheel. So it acts like a car caliper brake.
From that day to this, the emergency brake has acted as a safety valve, stopping the mechanism that strikes Big Ben if it's running too fast before it can cause any major damage. Now, this emergency brake has kicked in, and the team has to find out what set it off. To do this, they need to stop the hour strike without too many people noticing. So they wait until after Big Ben has struck midnight. The plan is to complete the work before the clock chimes 1. The team is spearheaded by Palace maintenance manager Mike McCann. Originally a marine engineer, he's known as the keeper of the Great Clock. It's a job title that's been passed down from generation to generation.
You see the ball bearings here, we're worried in case they may get damaged. And basically what happens is the faster it runs, the faster these ball bearings are flung up this incline. When they reach the top, they engage the brake, which stops the actual drum from rotating. But when they do that, they can get damaged. So you will be looking for any damage to those ball bearings in particular.
As soon as the 12th bong chimes, the team gets to work. First, the weight driving the mechanism must be lowered to take all the strain off the cable. Paul and an apprentice clockmaker head down to the base of the tower to oversee this procedure before Ian and Hugh can strip the clock.
We're now at the bottom of the weight shaft. Yeah, about 6 foot in. That's it, you're on the bags.
Once the weight is safely settled on the sandbags, Ian and Hugh remove the brake mechanism.
Thank you.
Things are taking longer than anticipated. The team have missed the 1 o'clock chime. They'll have to stay as long as it takes and work through the night if necessary to get the bongs back into Big Ben. Having sounded over 6 million bongs since its creation, Big Ben is rarely taken out of action. But the chime we hear today is not the same as it's always been. Because this is not the original Big Ben. On the 6th of August, 1856, the furnaces were fired up by John Warner and Sons at Cripplegate at their foundry in Stockton-on-Tees. Big Ben Mark I was created. Transported by sea to London, it was taken across Westminster Bridge on a carriage pulled by 16 white horses. Huge crowds gathered on the streets to cheer the arrival of London's most famous new citizen.
It was taken into New Palace Yard, where it was tested over a period of time. Denison, who had been instrumental in designing the clock and also the bells, wanted to provide the biggest sound from the hour bell. So he increased the size of the hammer whilst it was being tested. Unfortunately, he increased it too much, and a large crack appeared in the bell, rendering it useless. It had to be broken up, and the metal was recast, this time by Mears Foundry on the Whitechapel Road, a firm which still exists today.
The Whitechapel Bell Foundry is the oldest manufacturing company in the country. Alan Hughes, the master founder at Whitechapel, has worked here for over 40 years.
We have always claimed that the Whitechapel Foundry was established in 1570, and certainly we have clear evidence that we go back that far. But more recently, research suggests that perhaps we were more likely established in 1420, which of course is another 150 years. This may or may not be so. So we still, as it were, hang on to our known date of 1570.
The foundry was commissioned to cast a replacement bell almost 3 metres wide at the mouth.
This is our sales ledger from the period covering 1858, which details the provision of Big Ben, and we have an entry here dated the 28th of May 1858, made out to the Right Honourable, the Commissioners of Her Majesty's Works and Public Buildings, and it simply says 2A bell weighing 13 tons, 10 hundredweights, 3/4, 15 pounds, which with new metal we would have sold then at £2,401, 16 shillings and 9pence. But of course what we actually did in 1858 was to recast the first bell, which was broken during testing. So the metal from the first bell was brought back here as a credit, as it were, for casting the new bell. So we have, by credit of the old bell, which was weighed in at 15 tons, 13 hundredweights, 2/4 and 19 pounds, that worked out as a metal credit at then £1,829, 14 and 9pence.
As they didn't know how much metal a bell this size would need, they melted down 20,000 kilos of bell metal, a mixture of 77% copper and 23% zinc, at temperatures of around 1200 degrees centigrade. The process took over 12 hours. Big Ben, as this second bell was also nicknamed, was cast on Saturday, April the 10th, 1858.
That is the moulding gauge that was used for making the mould into which Big Ben was cast. And of course it's unique, it has only ever been used the one time.
This technique, used to cast Big Ben, is still the one that's followed today.
Big Ben is the largest bell ever cast in this foundry, and of course it was cast below ground floor level. In the mid-19th century there were considerable practical difficulties in lifting metal. 13.5 tons of liquid metal, there was no easy way of lifting that. So the whole of the mould was buried beneath the level of the ground. The metal was run through channels cut in the ground, so the metal simply ran by gravity along channels down into the mould. So the mould filled entirely by gravity.
Big Ben ended up weighing over 13,500 kilos. It took over 3 weeks to cool down and was then the largest bell in England.
So that was brought by the same means, the same horses brought it into New Palace Yard. It was tested and it was found to be sound.
Although it was 2,500 kilos lighter, the new bell was too large to fit up the clock tower's shaft vertically, so it was turned on its side. It took 30 hours to winch it up to the belfry in October 1858. The 4 quarter bells were already in place.
It was installed and it worked. It was connected up to the clock. It was satisfactory for several weeks until that too cracked in 2 places. These are smaller cracks, and you can still see these cracks today. The accusations flew, of course, between Denison and the founders. Denison said that it hadn't been cast properly, and the founders said that he'd used far too large a hammer on it again while it was in the tower. The Astronomer Royal suggested the solution, which was to turn the bell slightly so that the hammer wouldn't hit on the cracked parts, and also to reduce the hammer head so that wouldn't cause any more difficulties in the future. And from that day onwards, it has worked in conjunction with the 4 quarter bells.
Back in the clock room, 83 minutes have passed since the stopping of the strike mechanism. Westminster clockmaker Hugh Smith and his team's investigation into what triggered the emergency brake has drawn a blank. Instead, they must concentrate on resetting it to prevent any future accidents.
Yeah, look. It's not going to catch, is it? It's not going to stop it operating.
I reckon we should go for carbon fibre rebuild.
Can't beat the old-fashioned cast iron.
Once Hugh has given it a good clean-up, it's time for its reinstallation into the clock. But they have to get a move on. Big Ben has been silent for over 2 hours.
You've got the Allen curve,
Don't push it all the way in yet.
you're going to leave the pin off for now.
What we're going to do now, we're going to use the automatic winder to wind the heavy weights back up halfway up the tower or so, and then we'll have to release the train on the strike, which is the part we've just been working on, to get it to strike the right time, which will be 3 a.m. At the moment, it wants to strike 9 o'clock. The other side will start in 20 seconds. So the quarters will play, they'll play 16 notes, then there's a pause of 7 seconds, and then hopefully this end will go. And not too bad. It went well. Everything that we tried doing has worked, and as you just heard, it was all successful.
Well done, lads.
Another job done.
London's signature sound has been safely restored, but a much more crucial problem remains. Is the lean of Big Ben within safe limits? Throughout its life, Big Ben has witnessed huge changes to its surroundings. From the construction of monumental newcomer, the London Eye, across the river, to Portcullis House just next door. But the most significant threat to the Great Clock Tower has come from beneath its very foundations. In 1994, construction began on 11 new tunnels for the London Underground's Jubilee line. A 38-metre hole was dug for a new station just metres from Big Ben.
The Jubilee line tunnels are very deep below the surface and below the level of the foundations of the clock tower, and the nature of that is that there'll be a lot of settlement predicted as a result of the construction of the tunnels, and therefore there was great concern on the effect that that would have on the clock tower.
By 1994, the clock tower was already leaning by 148 millimetres. The invasive tunnelling threatened to add another 100 millimetres to the tilt. This would cause irreparable damage.
The tilt of Big Ben would have been of sufficient magnitude that it would have caused some unacceptable cracking between Big Ben and the Palace of Westminster.
So Professor Mayer and his colleagues came up with an ingenious solution to counteract the subsidence. It's called compensation grouting.
Compensation grouting involves the drilling of usually horizontal steel tubes in the ground deep below the foundations of the building or structure to be protected. Engineers can specify very precise and very accurate amounts of cement or liquid cement to be injected from holes in those tubes. That injection controls the movement of the ground and therefore controls the movement of the structure above it.
With the grouting in place, there was minimal disruption to the tower. Today, the total tilt of Big Ben is believed to be 180 millimetres. It's just within safe limits. A tilt of 200 millimetres could tip it over to critical, so the measurements are constantly verified. Duncan Lees is a surveyor specialising in laser measurement. With 25 years' experience, Duncan has used this technique on a variety of applications, from large-scale construction to creating special effects for Hollywood blockbusters. He's been brought in to get an exact measurement of the tower's tilt and look for any worrying trends.
How's it going?
Very well, thank you. How's
Good.
business going?
Yeah, not too bad. We've had a good day. The laser's been picking up a lot of information, even right at the very top of the tower. But the structure of this age must have been affected over time by a number of different events.
One of the things we have found is that the Thames itself causes the tower to move backwards and forwards, which you may have picked up with your data readings.
You mean in a day with tide coming in and out?
That's right. You've got 2 tides a day, and it moves backwards and forwards with each of those tides.
And what sort of range of movement do you think that is?
We're talking about something that's pretty small, actually. We're talking about something less than a millimetre.
We're kind of verging on the limit of the distance that we can get good data from, but we're still getting a good density of points. And so I'm confident that when we put all of the different scans together, I'll be able to show you, a complete tower, and we'll be able to look then at whether the points that I've collected show any kind of deformation. But you're monitoring this kind of thing anyway, aren't you?
We are, yes, and it'd be interesting to see how your data compares to what we've measured ourselves.
Okay.
Duncan will take his laser readings back to his lab to process. The results could determine Big Ben's future. It's the end of October and time for Big Ben to change from British summertime back to GMT. To do this, the clock has to be stopped, and it's the perfect time for some routine maintenance. The whole operation is managed with military precision. At 21:03 precisely, the lights on the clock face are switched off. This allows the clock hands to be moved without drawing too much attention from the public. The clock hands are advanced to 12 midnight. Big Ben's clock is stopped and will be started up at exactly midnight GMT. This gives the team precisely 4 hours to carry out an inspection of the entire machinery. Enter Malcolm Nichol, a specialist who'll be carrying out a forensic inspection of the clock using a form of non-destructive testing.
Non-destructive testing is the testing of components without subjecting them to any sectioning or cutting or other mechanical preparation.
The mechanism that Malcolm will be applying his technique to is on the shaft of the fly fan, a part of vital importance to the clock itself.
Let's have a look here. There's hardly any signs of wear on them at all,
After the fly fan has been dismantled, Malcolm has a brief window to carry out his investigation before the fly fan must be reinstalled.
This is a non-destructive technique called fluorescent magnetic particle testing. Effectively, what happens is we create a magnetic field across the surface of the component. And if there are any cracks which cross the lines of flux of the magnetic field, then the magnetic particles will be attracted to those defects. That's interesting.
Malcolm has spotted something he thinks could be a crack, potentially fatal for the mechanism.
Okay. Superficial corrosion.
But once he's looked closer, it turns out to be just a scratch.
We've got some
superficial corrosion, but it's not a problem.
Once Malcolm gives the all clear, the fly fans are reinstalled.
5, 4, 3, 2, 1, now.
The clock will run for the next 2 hours without the hour strike or the quarter chimes. The team now have just under 2 hours to monitor the clock's accuracy and make any adjustments to get it within 1 second of the new time.
This is Paul Robeson in its natural environment. It's stroking a clock.
It is, and in a happy state of mind.
Yes.
And on a Saturday night.
We don't do it for the moment. We don't do it for the moment. Yeah.
The dial lights are switched back on. At 2 in the morning, the quarter bells sound the Westminster chimes. The great bell strikes the hour, and Big Ben returns to Greenwich Mean Time. And it's vital that time is right to within a fraction of a second. Because just 2 weeks later, Big Ben plays a central role in the timing of Remembrance Sunday. Big Ben's future hangs in the balance. Duncan Lees has done a complete laser survey of the Great Clock Tower to find out exactly how far it's leaning. A tilt of 200 millimeters or over would put it in danger of cracking. The results are now in.
The laser scanning clearly shows that Big Ben leans. It leans to the northwest, and by a measurement of some 179, 180 millimetres from vertical. Now, this one-off measurement is no cause for concern. What we have to do in monitoring is to repeat the measurement exercise and see whether there is a trend to the movement. Now, a building of this importance and this stature, and with a lean of that much, it's crucial that the monitoring exercise is continued, and we can assess whether there is cause for concern in the way that Big Ben is moving and the way that the environment is affecting the clock tower.
Big Ben's future is safe for now. On the 11th hour, on the Sunday nearest to the 11th day of the 11th month each year, Big Ben tolls for those who lost their lives in war. This day is Remembrance Sunday. The whole operation is painstakingly planned. Big Ben has to strike at the exact moment that the field gun in Horse Guards Parade, 500 meters away, is fired in honor of the dead. As the sound from Big Ben has to travel further than that of the field gun, the gun must fire a fraction of a second after the bell. And this challenge falls to Captain Paul Greenwood and Sergeant Ryan Evans of the 10th Signal Regiment, 251 Signal Squadron.
I'm the London Operations Officer, looking after all the ceremonial events on the communication side, making sure that the communications and the time using is correct. The importance of Big Ben for Remembrance Sunday is we take the timing for the whole parade, which the general public would see on television.
In the hour leading up to the 11 o'clock strike, Sergeant Evans provides time control points, coordinating and synchronizing the events on the ground, from the playing of music, the arrival of the Queen and dignitaries, to the firing of the field gun on Horse Guards Parade. In the final minute, Captain Greenwood takes over the commands.
60 seconds to go. Hello, 6-9, this is 6-1. 30 seconds to go. Seconds. Flag up.
seconds. Flag steady. Fire, fire, fire.
2 minutes silence begins at exactly 11 a.m. The silence represents the exact moment in 1918 when the guns of Europe fell silent. The great clock tower at the Palaces of Westminster has become a national treasure, the iconic image of Britain. For the people who work behind the scenes to keep it alive and standing, there's no substitute.
What do you do for a living? I look after Big Ben. People just don't believe you. It becomes very addictive working on the great clock. But lots of people would say, oh, you must have the best job in the world. To be close, but it's a bit of an honour, really.
Well, I feel very privileged to be looking after it, yeah, definitely. If you'd have told me when I first started my apprenticeship that one day I'd be looking after Big Ben, I would never have believed you.
Big Ben has marked the highs and lows of the nation's history for over 150 years and looks set to ring the changes for centuries to come.